Hi, in this video we're going to talk about um, the normal distribution and how we can use it to approximate the binomial distribution. Now, these days, and if you plan to use Excel, of course, there's no need to use this approximation. Um, but if you're using tables, or if you're in a situation where you do not have um, access to Excel, and the binomial table is not long enough to have all the possibilities for the random variable that you're working with, then you can use this approximation and it's very easy. The rule, of course, is that n, or the number of trials in the binomial, times the probability of success must be greater than or equal to 5, and also n times 1 minus the probability of success, which we generally call q, must also be greater than or equal to 5. If these two conditions are met, then we can use the normal approximation to binomial. Now, some students have difficulty understanding how to do this and how to use the continuity correction factor, and I think the reason for that is because they don't have it solid in their head. The distinction between binomial being a discrete probability distribution and the normal being a continuous distribution. Now remember, for a discrete distribution, we can have the probability of an exact value, or we can compute the probability of an exact value. But for a continuous distribution, such as normal, we cannot have the probability of an exact value, or actually such probability exists, but it's going to be very, very close to 0 for an exact value. So because of that, for a continuous distribution, we need to consider a range of values, and then determine the probability for that range of values for the variable. So let's go ahead and use this example. The first one says probability that x is equal to 25. Now, if x is equal to 25, for a binomial distribution, which is discrete, we can compute the probability of an exact value, 25. But because we're using the normal distribution to approximate that probability, having 25, we cannot compute the probability of an exact value. So we need to create a range around that 25 and make a range of values from here to here, and make that approximation. Now, in general, in the discipline of statistics, if this is 25, you add a continuity correction factor, or you subtract a continuity correction factor. In this case, you would have to do both. You would have to add half, or 0.5, to make it 25.5 and 24.5 to be that range, so that you can compute or approximate the probability for x being exactly equal to 25, if you're going to use the normal distribution to approximate it. So in this case, you would add and subtract the continuity correction factor. Now, the next one says probability that x is less than 25. X is less than 25. Now, remember, x being less than 25, we're not working really with a normal distribution. This is a binomial distribution, which is discrete. So x less than 25 means probability that x is less than or equal to 24, because the number less than 25 would be 24. So 24 or anything less than that. So if I'm using the normal distribution, I want 24 and anything less than that in this end. So 24 and anything less than that. But I need to add the continuity correction factor and make this 24.5 so that that value of 24 is included in the range. So it would be 24.5 or less, as my answer to you in my handout tells you. Now for the next one, it says probability that x is less than or equal to 25. Now if I want probability to be less than or equal to 25, that means I want 25 also included in that range. But I want also 25 included in that range. So I'm going to have to add half a point to make my continuity correction factor added to it so that I'm also including the value of 25. And that's what my answer tells you. Next one, probability that x is greater than or equal to 25. So 25 is here. I want this probability of greater than or equal to 25. But notice it says greater than or equal to 25. So I want 25 included in that range. Because I want 25 included in that range, I would have to subtract the continuity correction factor and make it at 24.5 so that 25 is included in that range, as my solution tells you. Next is probability that x is greater than or equal to 25, or less than or equal to 33. But both of those values, the equal to them is also included. So I want greater than 25 to 33, but it says greater than or equal to 25. So I want 25 included and I want 33 included. So for those to be included, I would have to increase my range to include those two values. So it should go from 24.5 to 33.5, which is what my solution tells you. So we need to subtract the continuity correction factor from 25 and add it to 33 so that our range for the normal distribution calculations includes those two values, because that's what the problem is asking for. And finally, I'll just put it down here. It says probability that x is greater than 25 and greater than 25 and less than 33. Less than 33. So greater than 25 and less than 33 is here, but greater than 25 really means 26 or more. Now remember, we're working with a binomial variable, so which is discrete. So greater than 25, probability of x being greater than 25 really means 26 and more. Probability of x, probability that x is less than 33 is equal to really up to 32. Up to 32, because it says less than 33. Less than 33 for discrete variable means up to 32. So I want greater than 25, which means 26 and more. So I want really 26 up to 32. In reality, from a binomial perspective, that's what we want. But I want 26 and 32 included. So oops, what did I do? So I want 26 and 32 included in that range. So continuity correction has to start from 20, 20, I don't know why this is not working, from 25.5 to 32.5. So we want 26 and 32 included in that range, all the way from here to here, if I'm using the normal distribution. So, and somewhere in here, there we go. I have given you that answer also. And of course, how then we compute this is, let's assume that for this, whatever the n and p is for the binomial, we would say mu for the normal distribution is equal to n times p, and the standard deviation for the normal distribution is going to be n times p times q, which is the variance, but then we need to take square root of it because we take square root of variance to get standard deviation. So we use that as our mean for normal. We use this standard deviation that we compute as the standard deviation, and so for these problems we would use that mu, that sigma, and then if our values are these 25 or 2033 or whatever, we just compute the range around it. Okay, I hope that was helpful.